This is the fourth in our training series. Today we're going to talk about how we can go beyond the simple keyboards that we made with Keyman and use more complicated rules for more complicated language situations. We'll also talk a little bit about mobile design because mobile devices have some more options and different characteristics. Basic keyboards that we've talked about before are pretty easy to define. They generally have one character per key. They can be used for desktop and laptop, and they are technically based on a physical model of the keyboard. In other words, the layout that one sees on the physical keyboard is mapped in software so that one keystroke on the physical keyboard turns into the equivalent result from the virtual keyboard, which is kind of overlaid on in the computer's model upon the actual physical layout. So each physical keyboard has a number of layers. There's a default layer, a shift layer, sometimes a control, an alt lock, or an alt, and caps lock may be possible to define as well. And in Keyman and in other applications, finding these keyboards is actually pretty straightforward. So what I'd like to do is actually go to a keyboard that we looked at last time. We built something called Upside. It's a keyboard, and this is a project, a Keyman project. If I go to the Upside layout, I can see that we have a simple keyboard defined here. The simple keyboard is basically the same as the QWERTY keyboard, but in this one, we defined a few keys. For example, this A key was changed to have the value X, capital X. The S key has the value Y. This key has a non-Latin character in it, or a non-basic Latin character, basically a flipped character. It's actually from the Lisu script. And this looks like it's backwards, but it is a perfectly valid Unicode character. It has the value as shown here, A4D8. It's a basic QWERTY keyboard with 4 keys that have been replaced. And if I click on each one, one can see the Unicode character that's there. The output characters are shown in a character format here. I can go to the code, and the code actually describes pretty straightforward manner. It says that we've changed a few of the positions. So the keyboard back quote has been replaced with this character. The keyboard position for single quote has been replaced with another character. Keyboard B has been replaced with this Unicode character, and so on. These are simple definitions, come directly from modifying a design. Even say, oh, let's change the F. Instead of that F, I would like to have a capital F. By putting that there, that defines this key to be a capital F. I can go to the code, and now we can see that the capital F has been put in the position where the base layer F is there. So this is a simple keyboard. It's not too hard to define visually, and it has characteristics that you might want to use. In particular, for a lot of languages, we would like to rearrange some of the keys, get rid of a few keys that are characters that are not needed in the language, add a few characters. And so in the case of Native American languages, there are characters that have diacritic marks, and they can be placed upon any layer here. Shift and a control, alt layers can all be defined, and one can even so one can define things on all these layers interactively. It's also possible to build a version of this that is going to be shown while a person is actually using the keyboard layout, and it has it populates from the regular layout. That's a basic keyboard and has everything we need for many languages. Let's talk a little bit about some other options. that are not easy to do with a single code per key. For example, we might want to define diacritics in a separate way. We might want to say, let's have a special key that would add a diacritic, such as the diaeresis, or which is often called umlaut. And so we might say, oh, I want to take a key that defines the umlaut and add it to another key. But in some cases, like the O, perhaps I would like to make this into one code point, a single value, when I've typed in two separate characters. Now, the reasons for this is that many Latin letters already have these forms, O with the diaeresis. They're built into Unicode. And in fact, the particular Unicode character here, O, capital O with the diaeresis on it, this makes a single code, the file slightly smaller than it would be if there were two characters, two Unicode values for each visible position on the screen. And it makes a single code that's deleting, or that's deletable. And we can see that there are many possibilities in Latin languages, or Latin-based languages, A's with accents, D's with this symbol, S's with something underneath, or dots underneath, or tildes, any combination, and many of these are already predefined. So if we want to build a keyboard that allows this taking of two characters and composing them, turning them into a single character, we can do that in a keyboard. I'll show you in a minute how that is actually done. There are other kinds of things we might want to do. For example, in English, the double A is rare. And so if we wanted to say, oh, in English, or in my keyboard, I'd like to make the combination A followed by A to give an actual different character, an A with a line over it, or a macron. And so what we could do is imagine that somewhere in Keyman, we can say, set up a rule that says 2 A's in a row produce this other character. However, we're going to run into the situation, and I've run into this with actual keyboards. People say, well, it's rare that we have this double row, but I would like the ability to actually get that double letter in some circuit. So we can imagine that if someone actually wants to get 2 small letter A's in a row, we could give them some other rule. We could say, okay, type 2 A's to get the A with the macron on it, and then add 1 more A and O. That will go back to the whole. So these rules can be defined pretty easily in Keyman. And Keyman rules are a pretty simple concept, at least its basic part. In Keyman, there are basically statements of saying, given a particular context and 1 more keystroke, change it to give an output. And the context is what's already on the screen. And the keystroke is the new input, and the output is the result of this rule being fired or being triggered. In this particular case, we could find some simple rules in Keyman, and we'll actually go to the Keyman system and look at these in a moment. We can say, given the character given the character capital O, add this Unicode character to it, which is the diaeresis, and produce this 1 single character. Or the second example, and to make that a small a and another small a, and make an A with a line over it. And then add 1 more rule that says if we already have an A with a macron over it, and we add another A here, make a double A. So these rules all have the same parts: text, a new input character, and a result. And this result, and each of these pieces can be defined in several ways. And you can see that here I have them as characters that I can type within quote marks. I can also explicitly put a Unicode value in here by typing U plus and then the hex code for that. And then there are other ways as well. So on the upside keyboard, we don't have a very interesting situation here. But in the rules keyboard, which I have defined, we can start doing some interesting things. For example, rule that says take the capital O and convert that with the contents of what's on the backslash will give me this Unicode character, which happens to be the O capital, or the capital O with the diaresis. How do I know that that backslash has actually been changed? Well, the backslash here has actually been changed by saying this like this, that says the backslash key has been changed to this. I'd also add another rule that would say if I have a shift backslash, I would like to change O to something else, a different kind of character. So this is a simple rule that does that first thing. It takes two characters, a base character and a diacritic mark, and produces. I can do many of these. Here's the rule that says take an A followed by another A and produce another character. This character happens to be character for the lowercase a with a bar over the top. And then I can take another rule and say, oh, if I have that character and I followed it by an A, give me a double A. Got a couple of other things in here, but I just wanted to show you how these rules are defined. Now, you might say, okay, well, let me see what the keyboard looks like. Unfortunately, if I say, go back to the layout in Keyman, it says, I can't show you the design tab. I can't show you the visual picture because that doesn't fully represent all that's going on now because we've added rule. So, and one is defining a keyboard. The first thing you do is not go ahead and define all the rules. The first thing is set up individual keys with the layout that you might want to change their meanings, and then start adding the rules. Well, of course, we'd like to see that this actually works. So I can actually go to this and say, take my keyboard and compile it. By compiling it, it means basically check that everything's correct and produce something that can actually be executed. And now it gives me a number of statements. If all these say success, then I'm in pretty good shape. And I can go to keyboard and I can say test. So right now I'm in the mode where what I type in here will present or will show you what the output of the rule is going to be. For example, I type a capital O here that shows down at the bottom the character plus its Unicode point. And since I've defined the backslash key to be the diaresis, it says, add a diaresis there, and the diaresis has been added to this. You can see only one character in the output. What is that character? It is the Unicode code point 00D6, which happens to be a capital O with a diaresis over it, recomposed character. If I type capital O, but with something else after it, it doesn't combine that. If I type a capital O in Word, it doesn't do anything because that combination is not triggering any rules. I've defined another one, okay, with find a shift K backslash, and I can say O and a shift K backslash, and it produces another Unicode character. Let me remove some of these characters to make it clear as to what's going on. So capital O with shift backslash, and you can see that there is an O with a tilde over it, and it's a different Unicode point. Looking up at the rules, this rule right here is the one that was just. Okay, so we've got a simple rule that takes a character and a diacritic mark and produces a composed character. Now this works nicely because a lot of Latin letters already have composed forms, precomposed forms in the Unicode standard. And so that's why we can do some of these things. This isn't terribly exciting because it doesn't really change what people will see. If they were two separate codes, capital O, the diaresis diacritic character after it, it would visually look the same. But when we get to this other rule here, things start getting more interesting.
Does the order of the rules matter, or can they be put in any sequence?
The order of the rules matters. Yes. If you have a rule, the rules are processed from the first one through the last one. So if you have two rules that have similar context, put the one that is the more specific first, so that will trigger. So let's see, wait a minute, do that again. Yes, the order matters. And since it goes from the top, if you change the order of rules that have similar inputs, you will get different results. The order of the rules matters quite a bit. The other case that I talked about taking two characters in a row and replacing them with something else, want to make sure that this is working right. So I'm going to, again, let's make sure I'm compiled. Everything still compiles correctly in case I hit a key. And now I'm testing. So I'm typing an O, an A, and then I'll type another A. And you can see here that that A has been replaced by an A with a macron over. So effectively what's happened is that this rule, rule 19 here, has fired the character code A with a value, I'm sorry, with a bar over it is this Unicode 0101. So it's replaced with a precomposed character. Now, I want to actually have two A's in a row because I have another rule that says if I have that precomposed A with a macron over it, and I add another A, then it says, the context was 0101. I've added an A as the new input and replaced that whole thing, the context plus the new code, with the double A in here. So you can imagine that it's pretty easy to define rules that do simple replacements. I've defined another one here where I type a B, and 0041 happens to be capital A. If I type that, and you can see that the lowercase b, and then I typed a capital A, is replaced by B capital and A using this rule. Now you can look at the keystroke log and see what I've actually typed in here. These are the keys that I was actually typing, and you can see that the keys here are not indicated with the characters that were typed. They're indicating the actual physical position on the keyboard. So this is like K underscore A, which refers to the lowercase a position. I would want to was a shift in that same physical position, and that triggered the rule. Now, Keyman has a lot of things that I don't understand or don't know about very deeply. There's a way of going into a debug mode and actually looking into single stepping that will show you each step of the operation of these rules. I don't know how to use that very well, so I'm not going to show you that now. But suffice it to say that the Keyman application has a lot of ways that you can use to debug fairly complicated rules. Rules can be a little more tricky. The context of a rule, which is this left side before the plus sign, can have lots of other things in it. It can actually be what look like function calls or look like descriptions of characters in a more general way. So we can imagine that word context can actually be used to represent the left-hand side here before the plus sign. So for example, if I have lowercase abc and then I add a D to it, then I can say that my rule would be take the context, the ABC part, and instead put a capital D rather than a lowercase. That results in this. This is a simple example of using a keyword rather than having to reproduce what the context is. This context just refers to whatever is to the left side of the plus sign. There are also a couple of other functions which are kind of fun to play with. instead of defining individual characters, such as all the characters that would need to have diacritic marks on them, each and every separate rule, or each and every separate character with outputs for each and every rule, I might want to do something a little more clever. So there's something called index. Index is a way of looking up a character in a set of characters. And Keyman has this idea of a store. Basically, store says, I'm going to give something a name. This is like a variable in a programming language. I'm going to name this variable keys to be the set of characters, and I'm picking A, B, C, D, E here. This is an example right out of the Keyman rules, which I think is actually kind of a nice example because it shows transliterating characters. We have the keys here, and I've defined another variable called output. And you can see that these characters are not Latin characters. They're actually alpha, beta, gamma, delta, and epsilon out of the Greek alphabet. And so what happens here is that if we want to say, I would like to take A, B, C, D, E, and replace them with the equivalent alpha, beta, gamma, etc., what we have to do is say that we have a rule that says if there is a key, anything in the keys variable, A through E in this case, will be converted to what it finds in the output area, and it uses an index based upon what key or what value of key there was. So this says, basically say, give me something through the output based upon the value that was found from the any operation on the keys. And this will give us a way of typing alpha, beta, gamma, delta if we have a keyboard. There are all kinds of things that can be done with these rules that use the store, the index, and the any function. Now, here, the any function, you'll note, is part of a rule, but the left side of the rule, the context, isn't there. What does this mean? Well, it basically says, without a context, when you type a key, there isn't any context. It says, or without any rules, or without any conditions, take whatever key, A, B, C, D, E, and follow the rule to produce the output based upon this function indexing the output array. You can expect that the input or the keys and the output arrays would need to be the same length, and that's one of the requirements. Do another situation here. We had, for example, a set of vowels like A, E, I, O, U, and this is an image right out of the Keyman documentation as well. I could say that I have my vowels, my lowercase vowels, and I have the acute vowels. And these are 5 Unicode definitions for the precomposed lowercase vowels with an acute accent on them. And this rule down at the bottom here says, if I type a slash and then a vowel, it looks up the acute vowel. So this basically is a rule that says take A, convert it to, take A with a slash before it and convert that to A with a. So you can imagine that this would be a nice way of defining a couple of keystrokes, produce sets of characters with diacritics. Output could be as complicated as you want. You might have a slash before a vowel that would change to acute. You might have a backslash before a vowel that would change to a grave accent. You have a colon before a vowel that would change it to a diaeresis, and so on. One can imagine lots of different things that would be done here. But the rules are basically with a context, and a lookup in an area and the output. If the any part doesn't match, which means that I type something other than this case, an A, E, I, O, or U, then that rule won't fire. Let's take a look at something here. Now here, I have defined the input A, E, I, O, U, and Y. I've stored in a set of acutes or acute values, basically the characters for the ones with the acute. And I've stored another one called hook. And these are the characters that have a hook underneath. And you can see that the Y shape is slightly different. It's a different Unicode character. I've defined two rules here, and I've said, oh, if I have an input and then anything in the input followed by a left bracket, a left brace will give me the acute value. Any input followed by an ampersand will give me the value with a hook on it. So let me try this. Type the lowercase a, and I'm going to type, and you can see that that did exactly what I expected. On here it says A followed by a shift with a bracket, which is the brace, gives me that. E followed by that. And then I can try it with an E followed by an ampersand, and you can see it produces the E with a hook under it. So this is a simple way that I can define combining marks without actually having an explicit key on the screen which says, or on the layout which says, this is the combining mark. This is a way of doing combinations that might be reasonable for some programming language. I'm sorry, for some human language. This is similar in some ways to the idea of a dead key on a physical typewriter. One would type E and it wouldn't move the carriage, and then the next key would be put in the same place with a diacritic mark over it. This is a way of generalizing that idea of putting a context and another character following to produce an output. This is a little bit esoteric, but this came up in programming for the Burmese language, or using the Myanmar writing system. And in Myanmar script, they have a number of consonants, and each consonant has an implied vowel with it. So the A is a character that is this one. It looks like circles with the bottoms cut off together. A character. Its sound is ka. But if one wants to change that, you put a diacritic mark on it. You can change this to ki, or ko, or ku, or ka. And the way to do that is to add a diacritic. Now, most of the diacritics in the Burmese writing system go after. But visually, the Burmese ki sound is actually done by putting the E vowel ahead of the consonant. So when those visually are put together, this is the order in which people would expect to type them. You'd expect that to actually be the output you would get. Well, it turns out that Unicode has some rules about diacritics. Even though E is visually to the left of the consonant, the E vowel in the actual output text has to be put after the consonant. That means that if people type the E key and then the Ka key, they will actually be in the wrong order in the Unicode output. This drove me crazy when I first learned about this language, but it turns out that many languages of Southeast Asia, South and Southeast Asia, do the same thing. So what we want to do is set up something like a rule which says if you have a E vowel followed by, reorder them. So instead of having them in the order in which they were typed, recognize that this code 1031 followed by this Unicode 1000 just swaps the character. And that rule is pretty straightforward to make happen. So here we have the Burmese keyboard, and I've defined two keys. I've defined on the K key, the K value, or the Ka key. And you can see that I've done this with both using the key position and then the actual Unicode character as the output. These are no context, basically definite. On the A key, which is where the Burmese Burmese keyboards typically put E vowel, and just for grins, I put another one here on the C key. Now, what I've done here, I have actually put a simple rule that says if I have the E vowel followed by the K key, then I will get this output. Make sure that that actually works. Now, you're going to say, well, this is kind of confusing because it looks like I've just done the characters here. But this rule is defined here by the actual output. This output, even though it looks like the E vowel is to the left of this character, it's actually in the Unicode definition. So I'm going to change the rule. I'm going to change this to say basically that I'm going to swap these. And there's my more explicit definition using these using the Unicode constants. I've recompiled, and I want to just sure that when I type the A key followed by the K key, that the results down here, you can see that it's actually swapped the characters in a different order. That rule is going to be applied here, and it works out quite nicely for the Ka to make a key. Since there are a number of diacritics, and since there are quite a few different Unicode consonants for the Burmese language, I can do something else. I can do a store, and I can say, let the consonants be Unicode 1000, Unicode 1001, etc. It's going to be a longer list. I've limited to this. And what I've got now is a variable that says, let me look up and see if a character is in the consonants. If it is, I want to replace that character if it has the E vowel in front of it. I have also defined this key, the C key. So you can see, you can note if I type the C key, I get this other Unicode vowel. Bigger. This is another consonant. If I type that consonant by itself, it looks fine. If I type the E vowel and that consonant, this rule should reorder the keys. Well, somehow my rule is not firing here, but the intent here is that this rule would take, is a more general form. The rule in line number 9 is a more general form in the rule number 8. It's basically take any consonant and do the matching as appropriate. And I have to figure out what's going on here. But the basic idea is that reordering of some characters is a possibility. Suppose I have a keyboard where I want to type in the characters that with a Latin name for it. For example, I wanted to say, set up a keyboard where I would have a transliterating keyboard, where I would actually type in, for example, the K key and the A key to get the Ka character. Set up the K and H to give plus an A to give a different Unicode character. set up the G plus an A to give the da character, and so on. And these are rules that I can put in my Latin, or I'm sorry, in a keyboard and make it a transliterating keyboard. So if I have names for each of the characters, I can set up the base character and a context and a letter that will trigger the output of any or all of the Burmese language characters, in addition to the reordering of the individual characters in the case of the ava or the eval. This is a way of doing things where if someone is comfortable with a QWERTY or an AZERTY keyboard, but they have output in another writing system, they may be able to use this in a transliterator. So Keyman has extensive documentation, and I found this by using my favorite search engine and saying Keyman rules. Here it shows me all about using rules. You've seen some of these things about context. Stroke. Rule orders are defined here. They have a special order. They have statements that include the any statement, the context statement, and the index statement, which we talked a little bit about. There are other things that are more sophisticated that we don't go into today. The any and the indexing are quite often used. You can also have things like saying, oh, that input produces a beep. In other words, produces an audio version. You can find things to be dead keys where you actually type a character and then it produces nothing, and then the next character is going to match with that to produce the actual output, relating a physical keyboard that uses dead keys, and many other things here. So the Keyman programming language is pretty sophisticated and can do lots of. Here's one example here where it says take ABC and a character, and instead of just appending the D, take part of the context. So the context can actually be indexed, and it would say take the second character of the context, and the output here would be a capital D and a lowercase b, because the context is being referred to in a particular way. I'm going to define a new keyboard. This project, I can add a new keyboard to it. I'm going to call it rule. I'm going to call it. I'm going to call it an example keyboard. Defining a new keyboard layout. Pretty straightforward. To set it up so that I will have more than just a desktop. Go to the details and say I'd like to have a mobile device as well. I could restrict it to Android. I could restrict it to tablets. But I'm going to do more than that. I can do things like adding a on-screen keyboard and add a touch optimized keyboard. And this is kind of nice. It allows me several basic layouts. I'm going to pick the Keyman template for Latin, and that produces the output over here. So the layout here, the design is just B, C, D, E, F, G. I'm not changing anything right at this moment. On-screen keyboard, I can fill from the layout. And that will be change anything right at the moment because they're all basic underlying ones. But now I go to my touch layout, and you can see that the touch layout has actually built me a layout that is kind of different from the layout that you would expect on a physical keyboard. How's it different? Well, first of all, it's got only 3 rows. It doesn't have the symbols layer. It actually has fewer characters in each row as well. There is not the they're not the characters for the brackets or the backslash. Most of the punctuation isn't there. And why is this? Well, this is because a physical keyboard has a certain space. We're all used to that, but a layout on a mobile device is pretty limited. So it'd be nice to have fewer keys on each layer so that people's fingers don't have to be quite. The mobile layout definition is a little bit more complicated because we're defining for a different system. But one can see that by default, with this choice, there are 4 layers. The shift layer, the numeric layer, and the symbols layer are all set up, predefined for us based upon my basic QWERTY layout. If I had changed my layout to make some other keys at the beginning, those keys would be represented on the default and shift layers, because these actually refer to still the key position. So this is defined as A_L position. Each character on all of these layouts has a definition based upon the original positions of the keys on a physical keyboard. But there's something else you might notice. If I go to the default layer, I have a shift, which we'd expect works by taking us to the shift layer. If I actually touch that key, we can see the behavior of the key. It has a keycap value. In other words, this is what appears on the keycap. And the shift is this little image of an arrow. There's a key called special. There are several options here, but it's a special key as a modifier. And it also has an ID or a definition for what it does on the next layer. So that particular key says, take me to the shift layer. And that's what I want to do. But when it's actually running, that key has particular characteristics. I look at this one, 1, 2, 3 character, you can see it's very similar. It has a keycap value, but it says the next layer is the numeric layer. And this key here is a special key. It's called the menu. And this actually allows people to do things like change to different keyboard definitions. One is using it. Enter has particular values. It has special value. It has an ID, backspace, so on. But other characters like the G key are simply defined by their Unicode values. On each layer, we can have definitions here for all the characters. But with a quick setup, I have keyboard that's all ready to go. And everything can be defined here. But I might say, oh, I really don't want this particular symbol to be right there. I would like to have this symbol to be put somewhere else. So I can physically drag that symbol. You can see that the layout has been moved. I can say, oh, I don't really need this character. I'm just going to delete it. So by selecting it and clicking that little X key, here's. Oh, it's very easy for me to manipulate the actual contents of each and every layer. And then all I have to do is compile it. I've compiled it. Now, if I want to test, I can say test the keyboard, and it turns out that there's a very nice way of testing keyboard by using a browser.
So you deleted the upside down question mark, which then eliminates that key altogether, or can you add it back with some other symbol or letter or whatever? I mean,
good question. Yes, it's quite straightforward to. It's quite straightforward to go here and go back to my on-screen layout ball. Back to that layer. Say, oh, I really like this here, or I'd really like character here. I'm going to add a character to the right here. What I like it to be. Oh, Keyman has this very nice feature called actually say, what characters would you like to use? And so I can say range of, say, have the characters that I would like to use here. This character map lets me double click something, and you can see that I put that back here. That is now the character defined here. Character map, that's a quick and easy way of picking all the Unicode characters, and a scrollable window here within a particular range. It has the identity of the characters defined here. Oh, I can see, for example, this one is Latin characters, see with the stroke. So that answer your question?
Yeah, I guess I wondered why you didn't just leave that physical key there, so to speak, and just change it to something else.
Well, that could be done very simply by saying, oh, that physical key, I'd like that to be an X. And just changing it this way would be.
Yeah, okay.
But I might not need a key, or I might say, you know, I don't really need that key at all. I could change that key to be just a blank. And it will then show up in when the key is actually running just as a blank. It doesn't. There are a number of ways of doing that.
Okay.
Keyman has lots of options, and mobile layouts are actually quite nice to work with here.